it's super fancy. I don't know how well it's going to go when I'm far away then. So, but I read the reviews on Amazon, and someone said they use it to record their notes for their class, and it worked well. But I don't know if they record them like me, or they like sit at their computer and record like Patrick does. Who knows? Okay, this is last new stuff before we have a test. So if you are really behind on homework, or you just have no clue what's going on, now is the time to get it together. We laugh. Nervous. Okay, so we're going to talk about simple harmonic motion and how we can use trig and the derivatives of trig to show that. And so it says the motion of a weight bobbing up and down on the end of a spring is an example of simple harmonic motion. So like if you had a weight here, then as you let go of it, it's going to go down and it's going to reach this low point, right? And then it's going to go back up and it's just going to continue this process. Hey, does that kind of look like sine or a cosine curve? Oh. And so notice they're talking about S and B and A for the position, the velocity, and the acceleration at each of these values. So it says like at this point right here, the velocity is at a maximum, and the acceleration is at 0, and then when we go down here, this is when our velocity equals 0, because it's like our minimum. Mostly you're just going to practice doing these and the units on them. It's really not. There's probably a whole lot more physics with this I could do, but I'm not really that good at physics. Physics scares me a little bit. But okay, here we go. A weight hanging from a spring bobs up and down with position function S equals 3 sine of t, where S is in meters and t is in seconds. What are its velocity and acceleration at time t? I tried to do this new update for Smartboard, but I had all this stuff open already, so it said it couldn't finish it, and I had to do it later, and I think I screwed everything up. But I don't want to close down. Like, look at all these things I have open. I don't want to shut all of those things. So it's just going to be a rough thing. So this is just practicing your trig. And the great thing is when we're talking about simple harmonic motion, it's not going to be a tangent or a secant or a cotangent. It's going to be a sine or a cosine function. So those are the easy ones, right? So, Jarrett, what would the velocity of this curve be? And let's talk about units here. If S is the position, when we plug time in there, we would just get meters. What would the units be on the velocity? Yeah, because we're taking it with respect to t. So this would be meters per second. And Christy, what would the acceleration be? Meters per second squared. And again, I do this, but you could just say S prime, S double prime, or you could say V prime here, right? Like those all kind of mean the same thing. So far so good. I promise I think this is better than Friday's hers. But here's the new thing. Jerk. Jerk is the third derivative of the position function. So the first derivative is velocity, the second derivative is acceleration, and then the derivative of acceleration is called jerk. We don't talk about jerk that much, but it says it's the sudden change in acceleration. In your textbook, they talk about like if you're holding a cup of coffee, and there's a sudden change in acceleration, whether you hit the gas or you hit the brake, either one, changing your acceleration, and your coffee spills, like that would be called jerk. I did all this reading about jerk a couple years ago because a couple jerks in my class, that was a joke, kind of. Who was it? Tyler Vandermark and Philip Williams, for their senior project, drove around in their car and they talked about velocity, acceleration, and jerk, and then they said they didn't really understand jerk because Mrs. Dixon didn't even understand jerk, so how are they supposed to know it when their teacher doesn't know it? So I did all this like looking up about jerk, and there's even stuff about the fourth and the fifth derivative and like what's that's called, but it's like it seems like people just make that up. I don't know that that's really true or not. But on your test, I will ask you to find the third derivative. There's a little funny math joke. Like you can get a T-shirt that says "Don't be a jerk," only it doesn't say jerk. It just has like the derivative, the third derivative. And nobody gets that, but calculus people. So welcome to a new world of math jokes. So here we go. A body is moving in simple harmonic motion with the position of sine of t plus cosine of t, with t is in seconds and s is in meters. Find the velocity, acceleration, and jerk, and then find the velocity, acceleration, and jerk at pi 4 seconds. So we can do both at the same time if you want. We can do them separately, whatever you want to do. Some good old trig values. Again, with taking the derivative of sine and cosine, they just alternate signs, right? Like you just switch back and forth, so it's really easy to get mixed up. But hopefully it's not so bad. I think I'm gonna do this. Who hasn't answered yet? Kyler, velocity. Do I need to do the product rule? Do I have a product here? I have a sum, right? No product rule needed. Cosine t minus sine t. Do you want to go ahead and plug pi force in, or you want to do all these first and then plug pi force in? I'm going to plug it in. So I would get cosine of pi force minus sine of pi force. What's that going to equal? Radical 2 over 2, radical 2 over 2 is our pi force. So you get radical 2 over 2 minus radical 2 over 2, which gives me that the velocity at pi force is equal to 0, and my units here would be in meters per second. Sabrina, how are you feeling about this? What is the derivative of the velocity function? What's the derivative of cosine? And then what would I write here? Yeah, because the derivative of sine is cosine, but there's already a minus sign there. So when I plug pi force in this one, is it going to be 0? It's not, right? So I get negative square root of 2 over 2 minus square root of 2 over 2, which is... what would be negative 1/2 minus 1/2? It's negative 1, right? Negative 1/2 makes negative 1. So negative square root over 2 minus square root of 2 just gives me negative 2 square root of 2 over 2, or just negative square root of 2. Right? Because it would be like negative 2 square root of 2 over 2, because you add the top and you leave the bottom the same. Oh! This is not going to be a good day. Right? And then I can do this. And the units would be... squared. Meters per second per second. And then our new one, the jerk, Jacob, you're up. What's the jerk?
Negative cosine t plus sine t.
So it's like the exact opposite of our velocity. And what's going to happen when I plug pi force in this one? So 0, and then the jerk is going to be meters per second squared per second, or meters per second cubed. Meters per second cubed. When we have a test, I'm going to give you a question like this, and I'm going to ask you to do it and put the units on it. That's not so bad, right? So apparently I failed at putting homework on Math Excel, but I'm going to do that really quickly. And then you're going to finish your homework from Friday if you haven't done that also. So let me do that super quickly. Okay.